everyone. I'm so excited to be here. This is my very first RubyConf, and the last, so I'm excited to be an attendee, and can you imagine me being a speaker? So I'm so excited, and the last couple of days has been really amazing, and it's what I imagine RubyConf to be and more. So welcome to my talk, which is let's build a simple HTTP server with Ruby. The Ruby community has a few popular web servers that are based off of Rack. We have Webbrick, Puma, Thin, Unicorn, Passenger, and a few others. These servers are battle tested, so you don't really need to roll your own. There's no need for that. However, I think it's a great learning experience if you want to learn how HTTP and a simple web server works, so you know what's going on under the hood. At the end of this talk, we'll ultimately be building a very simplistic server. We will have built for ourselves a minimal HTTP, obviously non-spec compliant HTTP server and client. But before I proceed, a little bit about me. My name is Esther Olatunde. I write code that works sometimes on computers. And I'm based in Lagos, Nigeria. And I'm a developer at Lexu. And Lexu is a legal tech marketplace based in the UK. So let's dig in. So how many of us here knows what happens when you visit a URL in a browser? So this might seem a bit redundant to most of us, but I think we probably should start from here and connect the dots. The internet is a massive distributed client-server information system. Many applications are running over the web, such as browsers, email, file transfer, audio, video streaming, e-commerce, etc. In order for proper communication to take place between the client, that is your browsers, and these servers where these applications are on, these applications have to agree on a specific application level protocol, such as HTTP for the web, FTP for email, for file transfer, SMTP for email, and POP, and a few others. The application protocol that makes the web work is Hypertext Transfer Protocol, or abbreviated to HTTP. It is a protocol that web browsers and web servers use to communicate with each other over the internet. The HTTP protocol is perhaps the most popular application protocol that is used over the internet. And here is a basic overview of how it works. So like I said earlier, HTTP is a request-response protocol that describes how web servers exchange data with HTTP clients and browsers. So when you type in a URL in a browser, this is technically what happens. The web browser connects to the web server, sends an HTTP request via the TCP protocol stack for the desired web page, and the web server receives the request. It checks if the web page is available. If the page exists, the web server sends it back to the client. And if the requested page does not exist, the web server sends an error message. And this cycle, this request-response cycle, is essentially how HTTP and the web works. HTTP has specification, the full specification for this protocol. There is a doc for it. The specification is maintained by the World Wide Web Consortium, and the original version for HTTP is HTTP 0.9, which was released in 1991 by Tim Berners-Lee. And then there have been different versions since then. There's been HTTP 1.0 and the standardized HTTP 1.1. And there is also HTTP 2, which was standardized in 2015. And I think there is a proposal in the works for HTTP 3, and that's currently in draft. So if you are curious about that, this is the link, and you can see all the different spec that explains in details how this works. And if you want to join in to discussion about HTTP3, you can do that. So the URL as a syntax, and the syntax, URL essentially is a uniquely, it's used to uniquely identify a resource over the web, because that's, the address essentially where any resource is based on the web. And this is what the syntax looks like. The syntax has the protocol, which is the application level protocol, and then it has the host name, and it has the port. For the web, it's usually port 80, and you don't necessarily need to provide it. And it has the path or the file name. So for instance, when you visit this URL, example.com/Lagos, the browser issues an HTTP request and opens a connection to example.com on port 80. The server accepts the connection, and when the connection has been made, the HTTP client, that is your browser, turns that URL into a request message and sends an HTTP request. So the server, it sends an HTTP request to your server. The server, when it gets that request, it passes the request into a multi-line string that looks like this. And the first line of that string is the request line. This contains the HTTP method. In this case, it's get. It contains the request URI, which is also the path. And then it contains the HTTP version. Subsequent line after the second line are request headers, which are key value pairs that are delimited by a colon. And sometimes an HTTP request contains request body as well. So when you visit that particular URL on a web browser, so that request you saw earlier was me curling example.com. When you visit in the web browser, you get a lot more information, but it is similar. The first line always has that, but for browsers, they return a lot more information to you, more than curl does. So using that same connection that has been established with your server, the server responds with the content of the file or an error. The HTTP server sends, based on your request, it tries to interpret, if your server understands the request, it tries to interpret it and return, the content of the message based on, its understanding of your request. So, and this is the response that you get when you curl example.com/Lagos. So because I made Lagos.html up, it doesn't exist. So the example.com server is telling me, 404 not found. So this returns the HTTP version, the status code, and the status message. And that's also the response header. The response body also contains a bit more information about the response it's sending to you, and underneath that is the body of the response. So if there is an HTML page there, it's rendered there, or it's displayed to you. So this flow is essentially the basic implementation of HTTP, of how HTTP servers work. So there is the HTTP request. Your server should be able to accept a request, and it should be able to send back a response to you. This is the most common interaction that is happening on web servers today. And what we're going to do today is, let's implement this. Let's implement a server that can do this with just Ruby and no external gem. What do we need for that? We need a tool that can listen for bidirectional communication between client and servers. And this leads us to sockets. And socket takes you a bit to network and socket programming, but essentially, socket is an endpoint for a two-way communication between two programs that are running on a network. So a socket is bound to a port so that the TCP transport layer can identify the application that the data is sent to. And then your server forms the listener socket while the client reaches out to the socket. But you don't need to worry about like implementing this because the Ruby standard library has already implemented socket for us. And that brings us to the socket class, the Ruby socket class. The Ruby socket class provides access to the underlying operating system socket implementation. So it contains specific classes for handling common transport, as well as a generic interface for handling the rest. All the functionality in the socket library is accessible through a single extension library. And this is well documented in there. So you can go in and check it out and check out all the classes and all the methods that are attached to the socket. So that's really all we need, guys. So now that we have our socket, we can now proceed to building our HTTP server. But before we go ahead, based on all I've been saying, I want to identify the three main things we're going to build, like the three main features that our server needs to have to be functional. Our server needs to be able to listen for connection. It needs to be able to pass the request, and it needs to be able to build and send the response back to the client. So we're going to build that. To handle the listening for connections bit, here is how we do that. We require socket. You require the socket from the standard library. And then we need to define our server by initializing the TCP server class and having it listen for new connection on a TCP port. I've chosen to bound the server to port 5000. You can choose any integer from 100 and above. Next, we want to loop infinitely so that we can process our incoming connection one at a time. That will wait until a client has connected to until a client connects to our server, and then it will return a TCP socket that can be used in a similar fashion to other Ruby IO objects. So once we have that, we need to be able to read, once our server has been connected to, right, we need to be able to read the request that has just hit our server. And how we do that is using the .get method, and the .get method essentially reads the first line of the request. And if you go into the socket library, it explains the .get method essentially, and it essentially reads the next line from an IO stream. And because we've initialized our server to accept, there's an IO stream that is waiting to be connected to. So once anything hits the server, it's an IO stream, and using the .get method, we can read it. Then I'm just using that last one, using standard error to print that out to the console. And that's it. So with this, we have our server listening at port 5000. It can accept a connection, and it can print the first line of the request that we just received. It's worth it to note that an HTTP server does nothing, except listen to the IP address and the port that you specified until you make, if we run that, and until you make a request to that, it would just be waiting, listening for you to connect to it. So when you run this block of code, this is what you get. You get a response. You get on your console, you get this, and that's essentially the first line of the HTTP request, which is the get method and the path and the HTTP version. But however, like for a real server, we want our server to be able to read everything that has been sent to the IO stream from the request. So we do that using the .read partial 2048 byte method. You can, that 2048 can be size of the byte, but I think that 2048 is like, with 2048 byte stream, you can basically listen to almost every stream that hits that, every IO stream that hits that request. So with that, we get everything from our HTTP request. So when you run that, you get this full HTTP request that has gotten to our server, and we're printing that out. So now that you have this, we need to be able to parse this, because like I mentioned earlier, that is just a string. Like on your server just sees that as a string. Like it doesn't understand it. It needs to be able to parse it so it understands what to do with that string that it has received. Yeah, so it's just a string. We need to be able to parse it. And to parse it, I have this parse method. And this parse method essentially, because we know the request string, according to the HTTP spec, the first line of your request string has the method, the path, and the version. We're essentially splitting your first line into three variables, and assigning the first is the method, the second is the path, and the third is the version. So like that's very simple, and that does just that. And then we want that parse method to return a hash with the method, the path, and the headers. And for the headers, we need to parse that a little bit more, because the headers needs to be a string. It needs to be made up of an hash of key value pairs, so you know what is in the header that your HTTP request has. And the next slide shows a snippet code for how you parse the headers. So here, we're taking the request body from the second line, because we've already handled the first line. And then we're taking each line, and until we get to the end of the line, we're splitting it into key and value. And that's essentially what that does. It puts it into key value pairs and delimited by a colon. So at the end of this, like when you run all of this code, we should have a parsed request that our server understands. So our server knows what is what based on the request it gets. So when you run that, you should get this, which is an hash that has been passed. So this is our request. Our server knows that, oh, this is the method, this is the path, and these are the headers. And when we have this data, we can now use it on our server as we want. Yeah, so when we have this data, we need to now build and send the response back to our client. So to do that, I have this method that essentially assigns the path, by using our path request and fetching the path that's there, and it checks, the third line checks if the path is the home directory using the /. We respond with the server root path and the index.html. And index.html is a file that exists on your server. So it could be cat.jpg, it could be whatever you want your home directory for your server to have when you hit the home path of your server. And if it's not the home directory, you want it to essentially, look for the path, in your home directly and return that to you. In a second, I'm going to show you what the respond with method does. And the respond with method is also pretty straightforward. In there, it's checking, is that path, the file, is the file at that path, does it exist, right? And if it finds that path in your root directory, it essentially, we call another method which returns an OK response and reads that file to you. I will show you what the OK response looks like shortly. And if it doesn't, it returns a not found response. Yeah, so those are the conditions we are handling at the moment. And for a functional, production-ready HTTP server, that, condition can go, there can be different flow for that. And it would have to be like a lot more elegant than that. So this is what our OK response looks like. Our OK response, essentially, because we know, according to the HTTP spec, that the status code for an OK response is 200, we're just using that. And then we're also sending the body from the OK response to our response class, which I will show to you in a minute. And this is what the not found response looks like. The not found response just returns 404, and it doesn't bother. We don't bother returning the body for that. And here is what the response class looks like. So here, because we already know, according to the HTTP spec, the structure of what an HTTP response should look like. We're essentially picking the code, the body, and just creating a string that looks like what an HTTP response should look like, but we're using that based on the request that we've gotten from our server. And then when we have the response, we send that back to the client. And that's what our response class looks like. So this is what the full thing looks like. If you put all of the code I've just showed you, yeah, this is what the full thing looks like. We're requiring the socket from the standard library. We are requiring the HTTP request parser. All those methods that I showed to you earlier, I extracted them into a class called HTTP request parser. And then I extracted the response into another class. And then we're initializing our server and bounding it to port 5000, listening for connection, reading everything that hits our connection as a request, creating a usable request from that, taking that request, sending it to our response class so that our response class can parse that properly, and then we take that response and we send it back to the client, and then we close the client. And that's the simple flow for implementing an HTTP server. So what I want to do now is, let's see if that works. I want to run this and show you, what this looks like, what we've implemented so far. All right. Okay, I'm gone a sec. Yeah, so showing you again what I've just displayed in the slides. And this is in server.rb, so when we run this, Ruby server.rb. So we've started our server, and it ran that whatever it is in the server.rb, and we've bounded it to port 5000, and it's just waiting for a connection. And it will keep waiting until we make a request to it. So let's make a request to it. I want to curl localhost 5000. Yeah, so when you call localhost 5000, yeah, that's what's happening. You have the HTTP request at the top, and beneath it, you have the header, which is what we have in our index page. So if I want to, let me see if I can, so that's using call. Let's see what that looks like on a browser. Okay. Yeah, so you have the hello world. I have another file in there that is hello world, what's that? hello.txt, I think. So that's displaying hello.txt, and that's on the server. It's basically sending us back the resource because that exists in our server root path. There is one more thing that I will explain in a bit. I have an hello.ruby, so we can actually execute Ruby if the file is executable on your root directory. So let me show you that. Yeah, so I have 9 plus 2 there, and that's evaluating that to 11. So let's go back to the slides. I need to minimize that. Oops, sorry. Okay. Oh, that's not showing yet. Where was I? All right. Cool. Yeah. So I just showed you a demo of what that does when you run that. We can now that you can see we have our server handling basic resource for fetching. I forgot to show you if we request for a file that doesn't exist, it will handle that and show you 404 not found. So if you want to get, there are a few other things you can do. We can get a little bit ambitious. I already showed you that. We can try and make our server execute a Ruby file. And we can also make our server pass a query. So how will you, develop your server? Like modify what I've just shown you to pass a query so that it understands that this particular part that you just requested for has a query in it, and how would it handle that query? So to execute a Ruby file, here is what, you can modify that snippet of code that I have, and essentially check if that file is executable. So like just straightforward, you have the .executable method on the file class. Check if that file is executable, and if it is, use the backtick to execute that. And if it's not, you do the regular file.beamread that we've been doing, and just basically read that file and show it and return it. For parsing a query, we need to modify, if you remember our query parser method, we need to modify that just a little bit, because we know that according to the HTTP spec, when a path has the question mark sign, it is a query. Like, we've all agreed that that's the situation. And then we are essentially taking that path and splitting it by the question mark, and whatever is after the first index of that, the second index of whatever is after the split is your query. And then when you have that query, we can then modify that and send that back to your request parser, like your return your pass request in a way that, and you add the query to your pass request. So when that has been passed, you can see how you can modify your response parser in a way that, oh, okay, if this request has a query, this is the flow that you should go, and this is how you should handle that. But for the sake of this presentation, I didn't cover it in the demo, but we can go, you can play around with that and try and implement that. Oh yeah, I had that. All right, so that's our server, but do you think our server is ready to be made available on the internet yet? Unfortunately, I mean, if you're the only one that knows the port, the URL where that server is, and you're not sharing with anyone, fine. But if you want to make it available in public, I would say no, sadly, because it's missing lots of features, right? Like if this is the only server we have, our job would be so hard. It's missing lots of features, and there's so many features you can add to it. We haven't handled query parsing, for instance. We haven't handled security. We haven't handled like tons of stuff. But there's one particular issue I would like to highlight based on the current implementation of a server that I just showed you. And that is the current implementation I just showed you is susceptible, it's vulnerable to path traversal attack. And this is an attack, so when you put that server I have now on the internet, someone can essentially, using the .. to access directories, on my root server that I don't want them to access. So that's not secure. And there are different, so someone can essentially, if that's not localhost, it's an IP address that links to a server that I have on the internet. Someone can use the .. and access a directory and a file path that I don't want available, and we don't want that. And there are a couple of solutions and algorithms that have been written to prevent this, but I didn't cover that in this scope. But it's something to look out for, and you can play around with it with your friends. As Ruby developers, I'm sure we're all wondering, yeah, we've built this very simplistic thing. How does this affect my life? Where does rack fit in? And I just want to do a little bit of like 2 points to basically link that back to rack, and essentially why we use rack and why the rack is such a lifesaver is that rack has built an HTTP interface for Ruby. Most of the servers that we have, like that I showed you earlier, WebRig, they are all built on top of rack. So rack has defined a standard interface for interacting with HTTP and connecting web servers. So all of these features that we are missing, they've all been developed and thought through and built properly in rack, and they've handled query parsing, file handling, security features, and a lot of that. So so you can take, if you're trying to build a server that you want to put on the internet, I would advise you, build it on top of rack. So all that I've just shown you with a few lines of code, you can, have a server that does a lot more than I've just displayed, and you can have that, a functional production-ready server. And that's it. So if you want to read more, there is the HTTP spec doc, there is the socket doc, there is the rack doc, and I like digging. I'm very curious because that's how I learn. You can check the WebRig doc, the Puma doc, and see, how were these things built, and the connecting point to that. And I'm even challenging you should go into, if you can, try and dig into the rack and see where the beginning part, where the socket library that I showed you is used. You'll find that code interesting. And that's it. Thank you. Thank you so much.